Hello, my name is Flint Dibble, and I'm an archaeologist, and I'm here to help assess the evidence that was recently presented for whether Homo naledi buried their dead or not. In a sense, I'm doing a public peer review, if you will, right? Um, so I want to warn everybody that I will show images of hominin remains that may or may not come from burial contexts. So that's not your thing, tune out. If you don't live in a cave, maybe you've seen this sort of media blitz that hit the New York Times, every single media outlet you could think of. And if you pay any attention to archaeology, you've seen this. Homo naledi buried their dead in caves, new theory claims, right? Well, maybe if you live in a cave, you've heard of this too. Huh, I hadn't really thought about that. But either way, it's been a very calculated media blitz, kind of press releases that were teased for months in advance about these kind of these preprints that were released last Monday. They were embargoed and then went through the press, and which is interesting. It was a very successful media blitz in a sense. It got a lot of press, and I think that's a good thing for archaeology. I want to be clear about that. And I'm going to look into the second. They released three at the same time. I'll go into what all three were, but I'm going to look in detail at the one for burial, right? I have a experience and background that could bear on this, and I have a personal reason I'm interested in doing this. I want to be clear that personal reason is no beef with any member of the team. I have a lot of respect for all of the archaeologists involved and scientists and scholars involved, from the director of the project, Lee Berger, on down. I'm not trying to create any personal animus here, though I'm not sure if they're all going to like my critique, but that's science, okay? And it's been in public, so it's open game, right? So who is Homo naledi? This team, led by Lee Berger, first discovered Homo naledi about a decade ago. They started excavating in the Rising Star cave system back in 2013. And at that time, in 2015, their first publication, they reported about 700 plus specimens from this new hominin. And here's most of them, I think. This is a sort of fake image. It's a composite skeleton of many different individuals. The excavation in their sort of meter by meter trench, a little less than that, uncovered the remains from at least 5 individuals. And it really put this new hominid on the map. And because there's so much there, right? For one excavation. So it was a really cool find, absolutely fortuitous and really, really cool. And so, in particular, certain anatomical elements were found in articulation. So, for example, this hand was found together. So, there's no complete skeleton anywhere in this first excavation. But there is this hand, there's an articulated foot. I think they also mentioned an articulated ankle. And so, this sort of finds, especially comparing to other hand and feet bones, they give a sense of the locomotion of this hominid. And it's kind of interesting how the hand is more sort of adapted for sort of climbing and hanging in trees, and I don't like how people use the words primitive and modern, but that's what they mean is the hand is more primitive. On the other hand, the foot is more derived and therefore fairly similar to sort of us Homo sapiens, anatomically modern Homo sapiens. And so there's this interesting combination of features here that really helps inform kind of human evolution and understanding sort of different paths that are cousins, like Homo naledi living a few 100,000 years ago versus us, versus Neanderthals, versus different kinds of hominids, all sort of adapted and evolved. And so it's a really, really, really interesting sort of context and find, right? It's really significant and important from an archaeological perspective. And so this is a cave system that's in South Africa. And here, sorry, I guess I'm kind of in the way there. And so it's from South Africa, and it's in this area in northeast South Africa. It's considered the cradle of humankind or mankind. I think I like cradle of humankind better. And so it's this serious cave system. It was discovered by actually cavers who then informed the archaeologists. And as you can see, it's very complicated, right? You work your way, and most of the finds are in this Dinaledi subsystem. There's also occasionally discussed this Dinaledi Chamber. And there's some other chambers that are important geologically and for the path that you take. But there's some very tight passages, like I could not fit in there today. And so it's a difficult entry in. I think it's a 12-meter drop do I have, yeah, next up is a cartoon image of the Dinaledi Chamber. It's not to scale, so this is just a sketch, but you sort of drop in from a 12-meter vertical shaft, extremely narrow. Only very small people can fit through that shaft, which limits who can get in. It's a very small space as well. Difficult excavation. My hat is off to the excavators who had to deal with an extremely difficult situation to get any kind of proper scientific archaeological documentation done, and they did a very good job of that. I want to be clear. And so, you sort of drop in, and then there's this slope down, and then the excavation area from that first campaign's right here, right? And they found that commingled group of at least 5 of these individuals. Now, all the skeletal specimens in this cave, though they did mention in this new preprint one baboon tooth, but the rest of them, as far as I can tell from all the reports, that what's published and what's pre-printed, so pre-published, is all Homo naledi finds. So this is not a carnivore den, right? This is Homo naledi, and I guess really deep one baboon tooth. But yeah, so it's a very, very interesting sort of context as well, as in addition to it being an interesting find. And most of these skeletal remains, by the way, were on the surface, right? So visible, though they did excavate deeper in this small excavation area, just sort of 75 centimeter by 75 centimeter area where they found those 5 commingled individuals. So, all right. My role here is I want to be a peer reviewer, right? And I think it's important, especially given the kind of press that this article has gotten before going through the normal publication process. I want to do a public sort of peer review of this because I think it's good for, given the world that we live in, for everybody to understand how science works, because science isn't perfect. And that's okay, because humans aren't perfect, and we're the ones doing science, right? And so sort of getting a glimpse into how this happens and how papers are made stronger through peer reviewing is, I think, a really important thing to understand. And also sort of why we can't always go to what's in the press, because the press simplifies things and makes things less nuanced than they actually are, while the processes of science make sure that they'll be nuanced, or so I hope. So, all right. There were 3 preprints released on Monday that got all this press, right? And the first one was about art. So 241,000 to 335,000 years old rock engravings made by Homo naledi in the Rising Star Cave System in South Africa. That's the first of these. And there's these sort of cross-hatched engravings that the team is claiming are date to this time period and were made by Homo naledi. I'm not going to go into depth on this. This is not my specialty. But I would like to add that they probably need to find some clear dating evidence, because in 2015, their initial presentation of the context showed how cavers, even though they didn't admit to entering in there, the team that gave them the maps of the system didn't map out the Dinaledi Chamber. But in the Dinaledi Chamber, there was clear evidence that cavers had been in there, and that included kind of flags, survey pegs left behind. But it also included sort of the manipulation of skeletal stuff. So Homo naledi remains and these bird bones, which are basically, except for that baboon tooth, the only other non-Homo naledi bones in there that are not like micromammals, like little rodents and stuff like that. And so these cavers had manipulated, they've rearranged some of these bones in here. And that's kind of weird for a few reasons. One that I'd like to point out is that these bird bones, I mean, what were they? They didn't fly into the system. They were introduced by something like humans or Homo naledi, something like that, hominids. And so, but they were covered in calcite. So I'm not a geologist, and they need to test it, obviously, but I would argue that it seems unlikely that bird bones covered in calcite had entered this chamber just a few years earlier by these cavers that left survey pegs, for example. And so, we need to get dates on this cave art, is what I'm trying to say, because it might be that this chamber had been entered multiple times by different, Homo naledi, humans, etc. The other thing they need, I personally, from having read the article, I think they need to do a better job of demonstrating whether it's human anthropogenic cross-hatching are natural in this video, which is my background here. It's an image from this video that Lee Berger showed in a presentation on YouTube in 2012. The link is below, as is my full bibliography. The cave, and in the article, in the preprint, they mention how the cave has these natural kind of fissures that go in different directions and create crosshatches as well. And I don't know, I think they could have done a stronger job, a more detailed job of explaining and documenting why these were different and how they were different. They explain how, but I don't think they document in each case the why. But I'm not a geologist, and so I don't understand how cave walls fissure. I mean, it obviously, they're caves, has to do with the fact that moisture is trickling through things and dissolving. That's how caves are formed. Water gets in there and dissolves the sort of limestone and limestone inclusions like flint and dolomite, and it dissolves it and it reprecipitates into calcites like on the bird bones and on soils, or in some cases into stalactites and stalagmites made of calcite, and it's this dissolution that makes a cave system a cave system. And so I think it's really important to assess that and think through how they could be natural or not. In addition, if they're human-caused, which I'm not arguing they're not, but we need clear proof, right? Then they need to date them, right? Okay, the third preprint, which I'm not going to really discuss at all, is sort of saying, since we now have evidence that Homo Naledi buried their dead and engraved art on the walls of the cave, then what does that mean for their evolution? They're small-brained, small hominids with this complex behavior involving symbols and rituals like burial. Because remember, look, many animals, you think of elephant graveyards or different primates, they treat their dead sometimes in different ways. They might move them around or manipulate them or put them in a certain area, right? But burial, the act of digging a pit and covering over someone who you care for in a ritual with sediment, that implies a different kind of ritual, right? And so what does this mean evolutionarily if this is the earliest example of some of this behavior, like burial? And if it's a different hominid species that's very different morphologically and has a small brain, we can't comment on this article unless we can really prove and document that this engravings and this burials are proven, right? That they actually were burials that Homo Naledi did. So that's why I'm peer reviewing number 2. That's what I'm getting into, right? All right, so why do this on YouTube? Well, I have a camera. I have a hat. That's kind of cool. Makes me look like a real nice archaeologist. But this got a lot of press, right? And so I think I'm very justified because this was contrived press in the sense that Berger and his team very much hyped it on social media. They got in touch with a lot of journalists and made sure this hit in a clear way. And I'm not saying they shouldn't have done that. That's good for archaeology. But I'm just trying to say at the same time, we should show the public how the sausage is made, right? And we should get into this about how this is done. And like I said, I got zero beef with these people. They might have a small beef with me as I continue to critique their work. But I don't mean anything poor. I think they're all very good scholars, actually, in reality. And I think what they've found is significant. But why me? Okay, what are my qualifications? I'll give you a hint. I'm not a Paleolithic archaeologist, but I have a lot of experience excavating burials. I helped find and excavate as field director the Tomb of the Griffin Warrior in Pylos, at the Palace of Nestor in Pylos, back in 2015, and I helped organize the plans of how to record this and how to excavate this and all the whole 9 yards. So I have experience there. And another example where I was field director in what year was this? 2018. I helped find and excavate and open a monumental tomb from the late Roman period, and I've helped survey and excavate the burials in general from Egypt to the Crimean Peninsula in a variety of different contexts. So I'm very familiar with burial contexts. And what they look like when you excavate them. And these are, these are much later in time. So we're fairly sure that they are burials. After all, commingled skeletons constantly disturbed in the basement of a church, a Byzantine church. Those are burials. Same thing with these tombs, right? So yeah, I have a lot of experience excavating this material. At the same time, I have a lot of experience studying skeletal remains from burials. I am a zooarchaeologist and I study animal remains. Most of that is food trash, right? But a good chunk of it is buried animals. I've studied nearly 20 buried horses from several different sites. Some of them might just be equids, meaning donkeys or mules, but most of them were horses from several different sites across the Greek world, notably Phaleron, where this one comes from, outside of Athens. I've also studied several examples of buried dogs, buried hare, a buried rooster, and also I've studied offerings in mortuary, funerary context, right? So I'm very experienced studying this material, and I've published some of it that I've studied. Not all of it yet. I'm working on it. And I've also published on taphonomy and different skeletal issues in different kinds of contexts, right? And at the same time, my name is Flint, right? And it sounds funny, but I'm actually being serious here, because I have a connection, in a sense, to the question of Paleolithic burial. My dad, Harold Dibble, he was a Paleolithic archaeologist who excavated and studied material across Europe, especially in France, but also in Africa and Morocco, and directed a survey in Egypt, and studied material from Southwest Asia and the Near East as well. And so he, in particular, was a very rigorous scientist who developed new methods for how to record material, how to study Stone Age Paleolithic material. And in particular, he developed a series of rigorous methods for testing claims for hominid burial, right? And today, June 10th, 2023, is the 5-year anniversary of my dad's death, his passing. And I thought, given the news hitting about burial, that it would be timely for me to channel my dad as best as I can. And I want to be very clear. Please have a toast, if you're so inclined and of the age, in honor of my dad. He was very much loved by his family and his friends and his colleagues and his former students. I don't know how else to put it. He was fairly universal. Maybe not everybody liked him, but a whole lot of people did. He had a unique talent, a unique personality. So yeah, he's missed to my dad, Harold. And so I'm going to channel him in this. And this is hopefully in his honor to some degree, because his first example of really sort of looking into burial was at a site he was excavating in the mid-90s, Fontéchevade. And it was also mid to late 90s. It was coincidentally my first excavation. As a teenager, I didn't even want to be an archaeologist at that time. And I quickly fled and got into Greek archaeology because I was like, Stone Age stuff, God. So what was going on with burial of Fontéchevade was the very first excavators, these amateur excavators who were not professional archaeologists, uncovered hominid skeletal remains, including, for example, this cranial fragment, but a large number of them, and suggested these could be burials. And in the late 90s, and that was in the 60s, my dad and others like Phil Chase went back and excavated again. And they determined from the orientation of artifacts and the damage to them, and these fissures on the cave floor, that everything had been washed in from above. So these were definitely not burials. Everything, the stone tools, the hominids, and the hominid remains sort of settled in natural depressions and things like that, right? The second one was in the late 2000s. So before, maybe in the early 2010s as well. I don't remember the exact years. He excavated at Roque de Marçal, and this site was famous for the burial, proposed burial from the early excavators, who were professional archaeologists, of a nearly complete skeleton of a Neanderthal child. And with re-excavation, they determined that this was unlikely to be a burial because it was found in, a natural depression, rather than a dug pit, but a natural depression in the bedrock. And not only was there a natural depression, but there was a little bit of sediment between the bedrock and the burial, so a layer there, not the burial, the skeleton, and And then the skeleton itself was in two different layers that must have, sort of slumped in. And the skeleton was also slumping into this depression. So it seems very naturally deposited. It was fortuitously ended up deposited in this depression, which helped cover it in sediment more rapidly and protected this sort of concentration. And Grotte de Contrebandier in Morocco, he excavated what was known in the press as a 108,000-year-old child, the world's oldest child, and it's Homo sapiens. And in this case, he excavated it, unlike these other ones, which are early excavations, and he determined that it was probably a natural abandonment rather than deposition, rather than an intentional burial. Again, this is Bouchra, the reconstruction of the world's oldest child. So through these analyses, Dennis Sangaith and him and other colleagues, they published an article in 2011, and through here they lay out a bunch of criteria for identifying burial in a more secure way that would exclude a human burial, Neanderthal burial, Homo Naledi burial, from being some form of natural deposition left out and then covered over through erosion or other sort of geological processes, right? And so these, I've condensed them a little bit, so I apologize, Dennis. But these criteria include sort of, are these skeletal remains in a human-made or a natural cavity, right? That's important because the documented clear evidence we have for human burial is you dig a grave and then you put the loved one, the dear one, at the bottom of this human-made cavity, right? You don't dig a cavity, let it fill in with a little sediment, and then put the loved one down. And then you intentionally fill in the sediment all in one go, right? To bury it over, and whether you're protecting it or fulfilling a ritual, etc., that's what a burial is. And so this is all about context, right? It's about what can we understand about the sediments around the burial. But then there's another set of questions which relate to the skeleton itself. Is it complete and articulated? And this matters because when a skeleton, a person or an animal, a corpse is left just sort of lying around, it's prone to be modified by the elements. These could be scavengers. Of course, there's no scavengers deep in Homo Naledi or Rising Star Cave. But at the same time, it can be scattered around by erosional processes, sort of sediment moving, and especially over, a long-term geological scale, this can impact whether something is complete and articulated. But if it's buried all in one go, it's more protected and coherent, right? Is it also positioned in an intentional manner? So, you go back to that Roque de Marsal one, and the Neanderthal child was slumping in this weird, awkward position. But but burial is a ritual. The whole act of digging a grave and filling it's buried in a very intentional manner. And so most human cultures position skeletons in an intentional manner. Another thing that's common, though certainly not always, is accompanied by grave goods. Many of the burials I've excavated have grave goods, but also many do not. But then a really important one, which we've talked about, is how do natural post-depositional processes impact the context in the skeleton? And that really needs to be studied and detailed so that we can understand whether the evidence we have is altered later on, right? And how. And that can impact burials that we're arguing are burials, but it can also impact ones that maybe aren't burials. Okay, so let's dive in. Well, let's dive in. We got to get into the weeds now and peer review this paper in detail. Okay, so the abstract, much like the headlines, is conclusive, right? The language of the abstract, but not just the abstract, the language of the entire article, up until the supplementary information, is very conclusive, saying that these burials are proven beyond a shadow of a doubt. Recent excavations in the Rising Star Cave system of South Africa have revealed burials of the extinct hominin species Homo naledi. A combination of geological and anatomical evidence shows that the hominins dug holes, not maybe dug holes, dug holes that disrupted the subsurface stratigraphy and interred, buried the remains of Homo naledi individuals, resulting in at least two discrete features within the Dinaledi Chamber and the hill antechamber. These are the most ancient interments yet recorded in the hominin record, earlier than evidence of Homo sapiens interments by at least 100,000 years. Very, very clear language, very strong language. This is proven beyond a shadow of a doubt. And like I said, throughout the entire paper, until you hit the supplemental data, it's worded like this. And which is interesting, by the way, because scientists usually qualify things, equivocate. We're going to get into this because this is actually one of my biggest problems. I mean, as a peer reviewer, you can reject, you can accept, but you can also ask for changes. And this is one of the key changes. Like we're talking about, well, we'll see the quality of the evidence in a second. Okay, so 3 different potential burials are identified. One is feature 1, right here. This is a drawing of it. Just to be clear, this is not the difference in color of the sediment around this oval. The whiter bones were ones that were excavated. The darker ones are ones that are left in situ. And this is the feature. They suggest that feature 2 might also be a burial, but they don't describe it at all. It's just said that it seems from the surface to look similar to feature 1. And then there's this hill antechamber feature, which was excavated around it and left as a pedestal, then put in 3 different plaster blocks and removed from the cave and CT scanned. Okay, not excavated. So this is a partially excavated burial, a non-excavated potential burial, and a not excavated but CT scanned potential burial, right? This is what they have of their proposed burials. I'm going to focus mostly on feature 1 for the sake of time, for the sake of detail, and just because it has the most detailed evidence. It's clearly the one that if they're going to prove was a burial or not, they have a variety of different scientific samples, and they've excavated a large proportion, significant proportion of it. So the location of this is all in this sort of major Dinaledi subsystem. You drop through the chute here, and right where that slope is, if you remember, is where the hill antechamber feature is, the one that's CT scanned. Okay? About another, 15 meters or so 45 feet. You crawl past the engravings, which are right here, and then you hit Dinaledi feature 1. Sorry. And that's right there, and it's right adjacent to the trench, the 75 centimeter by 75 centimeter trench that was excavated in 2013 to 14. So we're talking, these two are clearly spatially related in terms of we can use the well-documented excavations here to help us interpret this feature, right? And vice versa. Because they're very close to each other, less than a meter apart, less than a few feet apart. While this is a very different kind of context. Here it is in that sort of drawing that's not to scale. You have the earlier, so you drop in here through the narrow chute, 12 meters, and then you have the excavation area, by the way, well, whatever. Next to that excavation area is the feature 1, which we'll focus on, this potential burial. And then further on the slope of the hill is the CT scan one, okay? We'll get into some of this and why it matters in a bit, but I just want to give you a sense of scale and where things are, because I think that's important. Okay, so let's dive into feature 1. So, the key argument here is laid out at the introduction to feature 1 as 5 clear points. These are their numberings. They number it 1 through 5. A combination of stratigraphic, anatomical, and taphonomic evidence supports this feature as a burial. The key observations are the difference in sediment composition within the feature compared to surrounding sediment. Different sediments. The disruption of the stratigraphy. So that would be the disruption of the stratigraphy is to open up and dig the grave. The difference in sediment composition is saying there's a different sediment inside the grave than outside. So that's an intentional infilling of the grave. And then there's the anatomical coherence of the skeletal remains. the matrix, and then two confusing things to me because I think they need better citation, is 4 and 5, which I think sort of relate to each other, is the matrix supported position of some skeletal elements, which is the idea here is that when a body decomposes, there's voids left, and if some of the skeletal remains are left supported by the sediment that it's buried in, it'll show up differently, right? And so that really relates, of course, then to number 5, the compatibility of non-articulated material with decomposition and subsequent collapse. So in a sense, I at least read these two as similar sort of argument, and we'll look at them. And look at all 5. So let's think about it. We're now at feature 1. 1 second. I need to rehydrate and have a quick sip of water. Rehydration is complete. And now I will have a quick sip of scotch in honor of my dad as we try to rigorously look at whether feature 1 is proven to be a burial or not. So, how was it discovered? It was uncovered in 2018, just sort of 8 centimeters below the surface, maybe something like that. It's a concentration of bones. That's how it was identified, as an accompanying soil disturbance, which forms a roughly oval-shaped distribution. And so it's clearly delimited on 3 sides, but on a 4th side, there's some of the bones from the individual, the adult individual that's in this concentration, were floating kind of further up in the space. There were 3 long bone fragments, fairly large ones. And the feature itself measures 50 centimeters in length and 25 centimeters in breadth. So quite small. I personally would like an explanation about how an adult Homo Naledi individual who has a height of about 1.4 meters would have been fit into such a small oval feature. But yeah. So at this time, they excavated the skeletal specimens from directly above or below the feature as they exposed its horizontal extent. So they came across some, they excavated them, and they started to recognize that the developing evidence was suggestive of a burial due to the spatial configuration of the feature and the evidence that the excavated material seemed to come from a single body. We halted further excavation and left the feature with identifiable skeletal remains in place across its surface, which makes sense. Having excavated burials before, as soon as you realize something might be a burial, you want to stop for a second and assess a plan of how to think about how to excavate and record and document. That's different from excavating something that's not a burial, after all, right? But at the same time, I would say one of my major complaints is they don't excavate the surrounding sediments in as clear detail. So when you just treat a special feature, and you only excavate the special feature and you don't compare it to surrounding stuff in a clear way, it makes it difficult to argue that it's special. We will look at how they do compare it a little bit because they do some sampling. But overall, I think that their methods are good. You stop, you reassess, you take some samples, and you think about it, right? I commend them for that. I think that's the right strategy in this really challenging small chamber. So, okay, some images of this. From overhead, we have the 75 centimeter by 75 centimeter larger trench with a sondage. These were the 2 later trenches. They don't describe what's in the south unit. They just mention that they excavated it. But they also did excavate this north unit, and that's where this feature is. And then this is feature 2 up here, which they left behind, mostly untouched. So as soon as they delimited it after excavating out some of the skeletal remains, like some of these that were floating, this was the part that they said to the south towards the first trench they excavated. They had these long bone fragments that are floating, and this is a photograph of what how they left it when they stopped excavating, right? And I want to be clear that they did stop excavating. So they had excavated those 80, I guess it was 130 skeletal specimens, if I'm remembering the numbers right. 80 or so they identified as being from this individual. But so they stopped, and then they cleaned a profile. So they sort of, when you think about archaeology, you have these kind of top-down views, but it's good to look at the sediment from the side to see different layers that might be on top of each other, and that's what a profile is, looking at it from the side. And that's also something that I would do as well. I think that you need to clean a profile, and ideally disrupt as little of the skeletal material as possible, to see what the sediment looks like and to see if you can identify a cut for a grave, the excavation, that kind of thing. At this time, they also started to identify skeletal material exposed on the surface of the feature. Many of the remaining elements are partially obscured by sediment and have not been removed from the sediment for the purposes of identification, right? And so this is, this to me confuses me a little bit. If they're presenting this as a very proven burial, but about a third or half of the remains are identified from being still covered in sediment and in context, and they haven't finished excavating it, I would think that some qualifying, maybe, perhaps, etc., is probably useful, but we'll look into that some more. So, okay, this is the profile that they cut. We're looking at, here is the concentration of skeletal remains. That's these white bits right here. And then these are the samplings that we'll talk about later. SA from outside, SB from inside the concentration, SC from in between feature 1 and feature 2, and then SE from the profile. And then this is just direct side on the profile, right? Okay, so their first claim, the difference in sediment composition within the feature and how it compares to the surrounding sediment, right? Is it justifiably different? To demonstrate this, they took this series of samples that I just mentioned. 2 from inside the feature, this is now overhead. Another bunch from the sort of surface level just outside of it. And then some from this area in between feature 1 and feature 2. And then finally some from the profile. Though they claim that these were from feature 1, but they're very, very spatially distant. So I'm less sure of that. But yeah. Okay, so they did some petrographic analysis. In a sense, what they did was something called X-ray fluorescence, XRF. And what this does is it gives you a sense of the chemical and elemental composition of the sediment, right? So you get bulk chemistry. You have a lot of variables, therefore. You sort of get a sense of how much iron there is, how much manganese there is, how much whatever, calcium there is. And so with so many multivariate analysis, what they chose to do, and it makes sense, is to sort of differentiate these groups of samples, which included samples from those that I just showed you, but also from around the cave system. You can group them along different variables through something called principal components analysis. And what this does is it sort of groups different things and explains the difference between those groups, right? So the difference between those in the burial from those without, right? And it sort of groups different variables into sort of principal components that explain it. So 51% of the variation in this sort of elemental chemistry between these groups is related to PC1, so really important one. And what this tells us is that they, it's sort of cut off before here, but it's those with negative loadings in calcium and manganese are from uncalcified sediments, and those with those in a pronounced positive would be from sediments with calcite, right? So remember, we're in a cave system where there's a lot of dissolution and then recrystallization as calcite. And some sediments they describe in other articles, they have several articles on the geology and geoarchaeology of this cave system, include these sediments with calcites. There's a few in the Dinaledi system, but there's also quite a lot elsewhere, right? And so you can see this, that what they're saying is when it's positive, it's uncalcified mudstones, and when it's negative, there's presence of this calcification. And so that really clearly distinguishes these samples, which by and large are from uncalcified contexts. But that doesn't really, the ones inside the grave, the ones outside the grave, the ones above the grave, are all similar. So, it doesn't really demonstrate anything about infilling. And it just says that this stuff is very different from what's in the Dinaledi Chamber and elsewhere in Dinaledi, where they sampled a large number of calcified sediments. Okay. The second principal component only describes 8% of the variability. And this one's important because it really distinctly delineates fossil-bearing sediments from sterile sediments. That's how the geoarchaeologists describe this, right? And what's interesting is the infill of feature 1, so the sediments inside it, they resemble sediments from elsewhere in the Dinaledi subsystem, such as those from the Dinaledi Chamber, where remains of Homo Naledi have been unearthed, which makes sense because they represent fossil-bearing sediments, right? So you can see SB, that's what's inside the feature 1. That is positive here with a positive PC2 score, and it represents fossil-bearing sediments, which are also there in the Dinaledi Chamber. So what does this mean? Why would they be similar? Does that mean that Dinaledi is also burying their dead because they have a similar score on this? Well, let's think about that for a second. What would make the sediment around fossils in the Dinaledi Chamber similar to the sediment around fossils in the Dinaledi Chamber? Right? Okay, but one last one to deal with is PC3, and that just suggests this geological process that's going on. Basically, during wetter periods, there's this laminated orange-red mud, and then during drier periods with sort of moisture coming and then drying, it breaks up. And so those with these different variables, PC3, they represent areas where this geological process is happening. Basically, in a sense, there's a lot of variability throughout, right? So whether you're getting examples of that process, including within this feature itself, part of it is yes, part of it is no. So it's not very clear as explaining anything. What is clear, though, is the big difference has to do with calcified sediment, right? And there's no difference between what's going on inside the feature and what's going on outside. So this is not this does not demonstrate intentional infill. A small difference, which there is a difference inside the feature and outside the feature, immediately outside, is this PC2, the one that we mentioned, fossil-bearing sediment. And I would say that this is actually likely due to diagenesis. What that is, if you study skeletal remains, is, once skeletal remains are deposited, they're in a matrix, and this is a very muddy environment. If you remember, we go back, laminated orange-red mud is one type of layer here. Unlithified mud class breccia is another. It's a very, very moist environment with calcifying, again, due to moisture there. Excuse me. And so in these kind of burial environments, there's an exchange going on, a transfer of elements between fossils and bones and the sediment itself. And these bones, for example, these fossils are stained with manganese, which helps explain why there's a negative score in the PC2 manganese. We can go back. I'll show you what I mean. Here we go. No, I guess I didn't quote it there. But if you go look into the details, there's a negative manganese there that's highly predicts this PC2. And there's manganese staining on a lot of the skeletal remains. And the small difference here of PC3 is unclear, but it relates to geological processes and not burials. So what we're thinking about is this PC2. And like I said, I my guess is it has to do with diagenesis. And part of my reasoning for this is that it occurs both in this feature, which is where there's fossils, right? There are fossils in the feature, a large concentration of them. And it makes sense that the sort of floor where there are no fossils doesn't show this, right? In the Dinaledi Chamber, they say they found a bunch of fossils there, and it also has that. But they're really far away from each other, the Dinaledi Chamber and the Dinaledi Chamber. And so if this is a sign of burial, what are they doing? Bringing the same sediment into each of these and depositing it in their graves? When you dig a grave, you usually use the sediment that's right there. And if this is distinguishing fossil-bearing from not fossil-bearing, and it's similar between Dinaledi and Dinaledi, where there's other differences that we showed, then that would tell me that this is diagenesis, and it's due mostly to the fact that there are fossils there that are, transferring elements between the fossils and the sediment, diagenesis. That's the only real explanation for this geology. And the geology report and the supplemental information number 1, it keeps mentioning that it's a sign of fossil bearing, not a sign of infilling. So, yeah, this does not demonstrate intentional infill. It demonstrates that there's fossils there. Okay. Number 2, the disruption of stratigraphy. So this is looking at, was there an intentional cut? Now, this is where we need to go in depth on a little bit of geology, right? And how we can identify a grave from sort of surrounding sediments, because we're looking for an excavation, a removal of sediment that would then be clear and create a new sort of layer where it's infilled, right? So, the feature 1, intrudes into the unlithified mud class breccia. We're going to get to know these, UMCB, of subunit 3B deposits. And subunit 3B deposits are the fossil-bearing subunit in the Dinaledi Chamber. They're basically the sediment that they're excavating through everywhere, right? And the angular mud class found in this subunit are fragments of Unit 1, the laminated orange-red mud, or LORM. Okay, let's translate this a little bit, because this is key. We go back to this diagram, which we've seen before. There's this sort of slope here where things have accumulated, and it's eroding down into drains. That's why everything's on even a mild slope over here, right? And pretty much most of this is on or in Unit 3, which is that unlithified mud-classed breccia, right? But there's an older unit of sediment, which is Unit 1, and that's this laminated maroon mudstone, or as they call it when it's in sediment form, laminated orange-red mud. Okay, LORM. And so that's what we're looking at here, is the relationship between this Unit 3 and this Unit 1. And you'll see what I mean in a second. So, okay. In feature 1, there's an abundance of laminated orange-red mud clasts with grain sizes greater than 2 centimeters around feature 1. And around feature 1, there seems to be a laterally continuous layer. This layer was not noted during our previous, and I'm sorry, I must have copied and pasted a little weird there. This layer was not noted, but the important thing is now. There's this clear layer of LORM, that orange-red mud, that was not noted during their previous excavations in the trench right next door, about a meter away, less, where the clasts were reported. So these inclusions, these little fragments of this mud were reported, but this layer was not. Here it is continuous in the profile, immediately to the east of the feature. It is disrupted in the sediment profile at the southern extent of the feature. And then in the feature itself, there's some of these clasts again, these sort of inclusions of this. So, okay, what does this mean? Let's look at what it means, because this is really, really important. So here's the image of the profile. Remember, we're looking at this from the side so that we can see different layers of sediment and how it goes. So, 5 centimeters, right there. These white bits are the skeletal remains that are left behind, right? That they've not excavated yet. They're talking about, here's the caption, feature 1 occurs within the unlithified mud class breccia, the UMCB, this brownish sediment, which is rich in orange class, so maybe some of these orange inclusions. A continuous laminated orange-red, LORM, mud layer beneath the excavated floor surface, this, dips near the feature where it becomes fragmented and muddled. So the argument here is that this continuous layer of the LORM, I love that name, this continuous layer of LORM must have been interrupted by Homo Naledi digging a pit here to put in the skeleton, the corpse of a loved one, right? So that's the argument. Disruption of stratigraphy. Okay. I got some weird issues here. What is this giant black thing? I have an idea, but it's very, very weird because it makes it so you can't really understand the stratigraphy. You'll see what I mean. Oh no, I'm hitting the wrong button. It kind of looks like, if you follow this, but I can't tell what's going on, meaning that this is a continuation of it that's interrupted in some way, but it's still sort of there. I'm not really sure because of this problems. And you see it's very blurry here, right? But you can sort of see something. I don't know. I don't know. I'm just looking at it. I've never seen it in person. So, okay, let's understand first of all what LORM is. Let's think this through. LORM is, and this is from publications by the team, by the way, Robbins et al. 2021. It's a laminated orange-red mud that has been described in detail for deposits in the Dinaledi Chamber. And it also occurs to varying degrees in other chambers. The LORM sediments represent low energy suspension, so not much movement, or at least at a rapid speed. They're low energy suspension deposits along the cave floor due to ponding of water in the cave. So it's during a wetter period where there's ponds or puddles that accumulate, and that puddling, that ponding, creates these layers of orange-red mud, these laminated features, right? UMCB, that's, remember, if we remember back, that's all this brown stuff, and it has these clasts of orange-red mud. UMCB is unlithified mud-clast breccia. It's also been described in detail by the team, where it is found as irregular accumulations along the cave floor. So all over the cave floor, this is what they're mainly excavating and what they can observe. It's that mud, the dark stuff, the dark brown. The UMCB sediments were largely derived from underlying deposits as a result of an auto-brecciation process involving wetting and drying of LORM accumulations, which disintegrated to form fractured, broken piles of UMCB. Okay, what does that mean? What that means is you have this underlying layer, and then when it gets, that's due to ponding water. When it's drier and it starts drying out, getting wet again, drying out, getting wet again, it starts brecciating, it starts breaking up. That's why you have these clasts, these inclusions of this LORM inside UMCB, right? Makes sense? It matters. I promise. It really does. Okay, but as I was saying, I have some issues with this profile photo. It makes it really unclear to understand what's going on, where's the extent of stuff. And even worse, it's really tough to understand where it is. So, okay, figure 3 includes an A and a B, at least in terms of looking at the profile and where it is. We've already looked at 3B and its caption describing this thing, right, where it was continuous until it was interrupted. What we've not, 3A says that it's a north-facing view, so we're looking at the south profile looking to the north of feature 1, showing the relation of the sediments around the fossils and the height of the profile. So this is feature 1. It shows the sampling locations. We've seen this photo, right? And whoa, I'm in the way. So we've seen this photo, but what's clear is they say that they're talking about the height of the profile. So the way I'm reading it is this is the top of it. There's a little bit of space. I can't tell from the angle. So we're looking at this like at a 3/4 angle, kind of looking on at the profile and down at the feature, right? And so there's some distance here between the feature and the profile. Then there's the profile, which goes till about here-ish. Maybe that's what this length is. And then this is the bottom of the excavated unit that they excavated their first trench, right? And this is the cave floor surface, right, which they label clearly. So that's what these arrows are for. This is the floor, this is the profile, that's the top between the feature. And then I have this yellow one because I don't understand how this picture of the profile, the one that they've been analyzing to make their point about the cut for the burial, for the grave, how it relates to this photo. I don't see this laminated orange-red mud continuous layer in this. And that I find to be kind of confusing. And they never really make clear in other images where this profile is. And I really wish they had, because this is looking north-south at feature 1 here, feature 2 here. Where is this profile? Is it 10 centimeters in sort of like this area? I don't think so. Not one of the images, not for the main preprint, but for the supplementary information, the first image even. We looked at this. It shows the sampling locations. This seems to show that they cut further back. And so here, let me go back because this is key. So there's this my guess is, they don't say this, that this is the photo taken when they stopped excavation, right? And then they came back and they created a profile. Why they left this part here, it makes it very difficult to interpret the profile for this feature. Do you see what I mean? And this is the profile that we're looking at. These are the samples, and notice that the samples even over here, not that far away. What, we're talking 10 centimeters diagonally away? It doesn't seem to show this laminated orange-red mud, laminated orange-red mud continuous layer. So we're talking about this just about here. It's just about 15 centimeters long, right? So yeah, we can see it again, even with this 5 centimeter scale bar, it's about 15 centimeters long. But I'm still very confused as to when this was, this profile was created in relation to this profile and the previous one, which they must have documented, the first one, which they must have documented from their first excavation. Why is this laminated orange-red mud, this continuous layer that they make such a big deal of, seems to me to be very ephemeral, right? I could be wrong, but that's how these images make it seem, at least. So some other images and explanation could help. So I guess the key questions that I have is this laminated orange-red mud continuous layer that dips and everything, is it in situ? If so, is this part of it, in which case it might be a natural topography, and is it cut or is it brecciated, right? Because throughout the chamber, they have examples of these types of layers being broken up by that wet-dry fragmentation, breccia, that creates this dark mud with these inclusions, right? So how do you document that this is an intentional, human-made, anthropogenic cut and not natural? So yeah, I think that the evidence presented for this argument that this is an intentional cut is very unclear. It's obtuse. The images need better explanation and improvement. To be honest, it's a very small profile, and it doesn't include the entire feature. I really think more extensive profiles are needed to determine if A, is this 15 centimeter long laminated orange-red mud layer an intrusive clast, which, to be honest, in the first excavation in 2015, the article there by Dirks et al. Said these inclusions can be up to 10 centimeters. So this is 15 centimeters. You know, is it intrusive? What is it? Is it ephemeral, or is it actually an in situ ponded surface topography? And if it's topography, it needs to, because let me go back really quickly. If this is the natural topography and this is a natural depression, then this could be very much like that Roc de Marsal Neanderthal child skeleton, where it is slumped and settled into a natural depression, which then, because its depression is going to fill in faster, which is then going to help protect it fortuitously compared to the other skeletal remains in the cave. And so that's certainly a possibility, right? And to examine some of this, we need to see if there's a cut, right? And that needs to be demonstrated in some way that demonstrates that it's not brecciation, which they've demonstrated in a lot of different articles about the process of this brecciation. Like 3-4 of them, something like that. So in sum, I got to say that this argument is not proven, and really they need better profiles, and they really need micromorphology samples would be my recommendation if you want to prove it. Obviously, you're not going to do that right this second, but it needs to happen in the future, I would imagine. That's where you can look at like the orientations of smaller sediments and try to get a sense on a more micro level, not just the chemistry, but the physical morphology of the sediments. Okay. Let me have a quick sip of water. So the next argument is the anatomical coherence of the skeletal remains. So they argue that the skeletal representation and spatial relationship contains mostly the remains of a single body, including 83 identifiable bone fragments out of, I think they record 130-ish in their catalog, that they recovered above and within the exposed circumference of the feature. Some elements visible on the surface of feature 1 are in articulation, and most are near related anatomical elements. There's some sort of coherence, is what they're arguing, right? Now, this is tough. Remember, some of this material was excavated. Some of it was studied as it was left because they didn't finish excavating this. It's half or who knows how much excavated because they're not done, right? It's a bunch of unknown unknowns. And only the white specimens in this drawing are what were excavated out, while the dark gray here were left and analyzed just on the ground in the sediment, still entrained in sediment within it. But even more confusing, 3 of the fragments that they excavated directly above and in contact. So some of these fragments that they're showing here that they excavated that are touching fragments from feature 1 represent 2 elements of at least one additional individual. So the main individual that they're arguing exists is fully adult. These 3 elements come from an immature proximal right femur and a shaft fragment compatible with an immature femur and a fragment of an immature proximal left humerus. Okay? So there's at least some fragments from another individual. Now, as an archaeologist who studied burials, this is something I trust more than some of the others. They identify a series of pairs, to a left humerus, a right humerus, a left radius, a right radius, right? But it's still very confusing because, to be honest, remember, many of these were identified obscured by sediment. And they talk about how the sizes seem to match up, but not only are they obscured by sediment, they're fractional. A lot of these fragments are just 2 to 5 centimeters. They can identify it's from a right radius. But to talk about it being the same size is really difficult. And to say that it's 100% paired up. And I think it's possible, but I'd say it's not proven. I think to improve this paper, improve it better, creating a table instead of a catalog to show what pairs up. But also another clear thing is even the excavated material, I forgot to mention, it was not cleaned because they're saving it for potentially biochemical analysis, which makes a lot of sense. But it's just hard to be conclusive when half of the remains you study are not washed or conserved and see what joins and things like that. And the other half are still in situ in the sediment. And then there's an unknown number of specimens that you still have yet to excavate. They are not visible at all. And to argue that these all come from one individual, and the catalog itself, in addition to not having a table, it does not clarify which are the specimens that belong to this individual, the 80-something out of the 130 that are reported. It also does not clarify how that designation was assigned in each case, right? And this is key if we want to really assess this data. And like I said, I think this is maybe one of their stronger arguments. They have a clear concentration of bones. It seems like they have these left-right side pairs. So I want to believe it, but I do think that there's ways they could document that a lot better. And I do think, given the context of the intermingled remains just 75, a few centimeters away, really, just right next door in the first excavation unit, the first trench. And given that they have not finished excavating this, I think there's room for a little more ambiguity. And to be honest, the supplemental material is quite clear and ambiguous. I mean, it's clear in its ambiguity. It says perhaps and tentatively and whatnot. It's the main article that presents this as very clear. Just like I said, the supplemental information for the geology is very clear that this is just fossil bearing. It doesn't infer that this is an intentional infill, right? But in the main paper, it does. So I think this could use better documentation and a little more ambiguity in its interpretation. Number 4 is really confusing to me. It's something that I've not encountered as an argument for a burial or not in my time reading or excavating burials. So what it's arguing here is that Some elements are in a vertical or subvertical orientation. And so if you think about it, that's reflective of decomposition with matrix support. So you have a corpse that is decomposing and it leaves a void. But if there's sediment there, some of those elements are going to stay in vertical position, right? Because they're not just going to fall into the void. And such matrix supported elements predominantly occur near the edge of the feature. Okay. I'll talk about that one in a second, and we'll talk about why this is red in a second. So you can see this. This is the only real documentation they provide of this. This is zoomed in at the highest resolution that this preprint comes in. They claim that there's some cranial fragments that are matrix supported, sort of somewhat vertical. I find that problematic because a cranium from an adult should be anyway. I don't really see that as convincing of anything. The rib cage is more convincing because why would the ribs stay upright unless there's sediment that's helping support them, right? To stay somewhat upright. I think better imagery, better pictures could help. I'm sure they uploaded a higher resolution version, but I can't assess it personally. I also would like to know more. Like I said, I've never come across this argument before, and they cite Bolter et al. 2018. And there's a real problem with this citation. It's a citation to an article by the same team, and it doesn't discuss this at all. It's about the paleodemographics of the individuals from the first excavation and the surface collection. It discusses, the ages and stuff it's seen, whether they were brought into the chamber, whether it's a catastrophe, that kind of thing. It never once mentions the orientation of specimens or matrix support or decomposition in this way, in any way like this. So I don't understand what this citation is doing here, and I personally would like a comparandum to explain this argument because I've never seen it before. Another key thing that I have an issue with is these matrix-supported elements predominantly occur near the edge of the feature. And that actually kind of makes sense in a natural depression, right? In a natural depression, the edge of the feature is where the sediment is. And so there's more matrix there. It's also where it's going to fill in first in this slow-moving mud environment. It's going to fill up in that direction slowly. And the edges are where you expect more matrix support. As regards to the vertical question, what they do is they say we have some vertical elements. We showed them the crania fragments, the ribs, and a few others. And they compare them to the surface collection, right? And they do that in this figure. This is one of those rose diagrams, right? And they say that the presence of these steeply angled fossils, such as a near vertical femur fragment, and orientations at every direction, but they don't map out the orientations, by the way, from this feature. That's just what they say, suggests skeletal materials were also buried and have not been substantially moved through post-depositional soil movement. In comparison, the surface material tends to be at shallower angles corresponding to the shallow slopes of the chamber floor. All right, wait a second. They say that because there's some vertical stuff, it's not been moved. But remember, they described when they first found this feature, they found some elements to the southern edge that had clearly moved quite a bit, over 5 centimeters away. So I don't think that necessarily proves it, but we can see. Then they compare this to the surface material, and here they've mapped this out. These are all the specimens on the surface, and this is mapping out in 3D the dip, the plunge, sort of in the vertical angle of specimens that have an orientation. And then this is sort of where they are in the cave. And this corresponds well. Remember, this is on a slope, and a light slope at this point. So it's almost horizontal, but dipping slightly, right? And then it's all going in one direction because that's the direction the mud is very, very slowly flowing down the slope towards the drain, right? But I have an issue here that's personal. They mentioned that for fossil fragments large enough, they mapped 2 endpoints. So they were using like a total station, 3D scanner, or whatever. They mapped these 2 endpoints, and they calculated the plunge angle and planar orientation following Brophy et al. 2021. I went to Brophy et al. 2021. It's a description of teeth. It never once mentions orientations. It never once mentions this method. Where did they get this method from? This is the exact same method that somebody named Harold Dibble used at Fond-de-Chevade. And it's become more common of a method since the 90s due to that. And so, Yeah, so like I said, I have personal reason. You should probably credit the method, even if you don't like the results. Like I don't know. Um, okay, I personally don't see this explanation as adequately explained. I don't see any comparanda, citations, or explanations for this section of the recording methods. And there's not much data other than a few blurry photos, right? And so really what it's coming down to is that some of these materials are vertical and many of them are supported by a matrix of sediment, a matrix of sediment. And what that means is, well, when things are moving around too, that can happen. You push up things. Okay, lastly, the compatibility of non-articulated material with decomposition and subsequent collapse. So they argue that that there's articulated material. Okay, I actually wish they'd provided some photos of that because I've never seen an example. They also claim that there's some stuff in close anatomical proximity. For example, most left-hand elements are within a 7 centimeter radius, so 14 centimeter diameter, of each other. And remember, the pit is only 25 centimeters wide. So 14 centimeter diameter is taking up quite a bit of this pit, this feature. And so I don't see their arguments very clearly laid out for articulated stuff. But let's look at this non-articulated stuff. They suggest that some of the material is matrix supported near the edges, and then other stuff collapses inwards because of decomposition, right? And so there's voids into which the bones comprising anatomical units, head, torso, limbs, could collapse, resulting in the displacement of fragments and joint articulations. By contrast, the decomposition of a body with a natural depression on the cave floor results in a different pattern of displacement. They have no citation here. They have no explanation here. What is your documentation that demonstrates a body that decomposes on a cave floor decomposes and has a different set of voids that go different in a different direction, I guess, than a body inside a grave? And they don't really explain that. I guess they go back to this figure with their 16 mapped elements. But those, remember, these are things that are on the floor surface today. They haven't been covered up over hundreds of thousands of years, and the stuff that's buried is different, right? I don't know. To me, looking at this image, without thinking about what they describe, as an archaeologist, right? What do I see? I see clear evidence for post-depositional processes that are displacing and breaking up stuff, right? I see some evidence perhaps for this being a reasonably coherent concentration of bones, which arguably, once you study all the material properly and not in a preliminary fashion, will end up being arguably mostly from one individual. Okay? And there's some anatomical coherence, head, torso, limbs are scattered everywhere though, right? Some of it is matrix supported, others of it is not and has collapsed into the center, right? That's that decomposition thing. And that, to me, it's totally ambiguous whether this is a burial or not. I've excavated a lot of burials, and to be honest, they're usually protected by sediment, and they're much less disturbed than this. Studied a lot of burials. If you want to talk about decomposition affecting how things change location, well, that happens in every single burial or not, and whether it's a burial or not. And this is very displaced, and the quality of the evidence is difficult to make such a clear argument at this point in time. Okay. Final problems. They ignore conclusions from earlier excavations. This is really important. These two trenches are right next to each other. This is only 75 centimeters. This is the feature. It's right next to their earlier excavations, and they completely ignore the hard data of these earlier excavations. The earlier excavations, in the presentation of the context, authored primarily by geoarchaeologists and people that are thinking about sedimentary context, they have articulating elements, including hands and feet. We've seen some of them earlier, right? But only little bits. They come from all these bits come from 5 different people at a minimum in this 75 centimeter by 75 centimeter area. And on top of it, they have matrix supported elements, including this almost vertical long bone, like they mentioned a nearly vertical femur in feature 1. And in all these cases, these were explained as evidence for the different ways that sediment has moved after the deposition of these individuals, right? In the hundreds of thousands of years after, sediment is moving in different ways in different places because it's a very slow mud flow. It's all mud, right? And drying and cracking and damaging stuff. And they documented quite clearly how these things, these articulations combined with vertical stuff, can be the result of post-depositional processes, right? Not due to burial. That's what they said in 2015. And fairly clearly, the most important thing I think that they documented is that the study of those 700 remains in 2015 showed not a single example of a spiral or a green fracture. Now, this is really important as a bone person like I am. So what does this mean? First of all, they could not document this from this new feature, right? Feature 1, they couldn't document it because they didn't wash anything. They documented no taphonomy on breaks. The stuff was still unexcavated. But not a single example of it from 700. So what does that mean? When bone fractures, it's different if it's near to the death of an animal or a human or a hominin than long after. The reason why is that fresher bone has more soft tissue with it and grease embedded in it, and so it breaks differently. And it breaks in this kind of spiral fracture that means that it broke sometime around the death of somebody before the bone had dried out. So, it takes time to decompose the body, then time for the bone to dry out. So, within a year, 2 years, 4 years, it depends on the environment. And how quickly the soft tissue decomposes. But within a few years, then it no longer fractures in this way, and instead has a dry fracture, right? So these patterns are interpreted, the dry bone fracture patterns, to be due to post-depositional sediment movement within the chamber as units 2 and 3 are reworked. Units 2 and 3 are reworked by that drying, wetting movement downslope, as well as unintentional damage by cavers or others entering the chamber much later, right? And so all of this sort of work that was done on a much more significant assemblage of bone that was studied in a sort of final presentation and format, unlike the preliminary sort of study that's presented here, it would directly contradict the arguments that they present here. And in particular, they go so far to mention several times that they think that they want to use this feature to reinterpret the earlier excavations instead of vice versa, right? And so they say that instead, what this suggests is that there's concentrations that are spatially identifiable, although with substantial commingling and loss of anatomical ordering of much of the material. A parsimonious explanation for this configuration of skeletal remains is that these remains may be a palimpsest of burials that have sequentially disrupted each other. In this hypothesis, early burials were disrupted when pits were dug for subsequent burials. So that's why there's all these commingled remains over there, where there's a hand and a foot and different things mixed together. It's because this is a cemetery that's in use over time. And later burials interrupt and mingle with earlier burials. Okay, there's not a single citation or anything to the many times this happens in the archaeological record. I personally have studied a whole lot of animals that are in this sort of situation, right? And we have some senses of how that works, right? And so I suggest reading, I don't know, anywhere in the world, later period cemeteries, and looking into the kind of taphonomy of this. It's not something that's been understudied. And at the same time, I'd argue that one thing I notice a lot of are those spiral fractures, because when this is happening, it's a continuous use cemetery, and oftentimes new graves are being dug within a few years of a previous grave and disrupting it and breaking it, and you get spiral fractures some of the time, right? And so the fact that there's not a single spiral fracture from that earlier, larger assemblage makes me question this reinterpretation of why there's commingling there. I find it to be unconvincing, in particular, very unconvincing. I was originally going to analyze the CT scan, but I think I've rambled on long enough. It's the data quality here is even lower because it's just these blocks in a CT scan, and it's not worth the time. It's better to have delved into the higher quality data set of that partially excavated feature. So go read it yourself, or wait until the real peer review comes out for eLife, where they've submitted it. Okay, my last little comment, I suppose, is this is a bibliographical nightmare. I have graded undergraduate theses with much better bibliography. About half of them are citations to the team's own research, and there's errors there, as I've shown. Some are citations to basic methods, which is fine. You need to do that, but as noted, there's also lots of these are missing or miscited. Let's document your methods a little better, please, so that scholars can understand how you did things. And then there's only 14 citations to other archaeological literature. And none of these are engaged with in depth at all. None of them are quoted, none of them are paraphrased. They do not engage in the least with any of the arguments out there. The hundreds of articles published, by my dad, but also by lots and lots of other really good scholars on the evidence for burial this early in the hominid record. And so this is really a nightmare. Okay. Let's return to these criteria for identifying burial that Dennis Sangaith and my dad and others have published. Are the remains in an anthropogenic or natural cavity? I don't know. Are they at the bottom of the cavity? Not addressed. Are they in intentionally filled sediment? Certainly not proven. The sediment's different, but that's because there's just bones and they're leaching elements between the sediment and the bones. Is the skeleton complete and articulated? There might be a few articulations. Complete, you have to excavate more of this to show us what's there. Is it positioned in an intentional manner? They claim that it's flexed up, this 1.4 meter, 140 centimeter high individual in a 50 centimeter length grave. They claim it's extremely flexed up. I guess that would be intentional, or it's just sort of slumped into a natural feature. But you need to demonstrate that a lot better, and you need to finish excavating, right? Is it accompanied by grave goods? They do argue there's a stone that's not a stone tool that's in the CT scan. I'm not going to get into it. Someone else can. And then lastly, how do natural post-depositional processes impact context and skeleton? This is not explored almost at all, and this is the most important one of all of them, because it's clear that there's all these natural post-depositional processes in this cave that are impacting the movement of sediment and the things in the sediment, meaning the Homo Naledi bones. And so the fact that this is not described in detail, especially since they disagree with the 5 articles that are written about this, where they say that this is a continuous use cemetery with lots of burials, or they imply it, that's a complete reinterpretation. And their arguments for all their things are really reinterpreting that earlier contextual reports. They need to address that in detail. It's not done at all. So returning to the abstract, is any of this proven? It's stated so confidently, beyond a shadow of a doubt, these are the most ancient interments yet recorded. Argue no. So as a peer reviewer, I'm left with some choices. It's obviously not just accept, period. It's not even minor revisions. The question is rejection or major revisions. It's cut off there. My arguments for rejection. This is a really sloppily written paper. The supplementary information is better, but the paper itself is very, very sloppy. And in particular, this lack of bibliography I see as, and the miscitations are really weird. But the lack of bibliography I see as slightly disingenuous. They should spend the time building a secure argument with parallels to other literature and scholarship on how these are burials. Instead, they're waiting on the reviewers. They're saying, here's our evidence. Tell us what you want us to argue with. Do you want us to argue with Sangaith et al. 2011? You suggest the articles and scholarship we should think about. And that's really lazy. And it's kind of gaming the system. They should develop their own argument, and then the reviewers can make suggestions on how to strengthen it. Instead, they don't even make an argument. They don't make an argument at all with any of the literature that discusses rigorous approaches to hominid burial. And so this is really lazy, and it's actually asking the reviewers to do a lot of work for them. Why should the reviewers, who aren't paid, who don't get really much credit for reviewing, waste time doing so much work for them? If I was a reviewer, I'd be really pissed off, and I'd have a knee-jerk reaction to reject for that reason. I probably wouldn't, though. I firmly believe in the ethics of peer review, where the goal is to improve this paper. But I would argue for very major revisions to the presentation, the writing, the way that it is formulated, and to the images, all this kind of stuff. I want to say that the science is overall decent. They did a decent job. They made what are logical decisions in how to excavate and sample. Stopping, waiting to think through the best strategy makes a lot of sense. But what it means is the quality of your evidence is much lower, right? And that's not acknowledged. That's not acknowledged. Instead, they say, hey, we're preserving this for future investigation. Great. But at the same time, you're also saying this is definitive. And so this needs major rewrite, major reworking of images, and it could end up being a good cautious paper that honors both the work of the larger team, who are very good scholars, and it also is contextualized within broader archaeological literature. And I sure hope that that's what comes out of this. If I was a reviewer, I'd want to see the revisions again, though, before approving. Because in particular, the bibliography, they're very lazy with that, and they need to make sure that they do a good job with it. But obviously, this material is very significant. It's very important to our understanding of Homo naledi, of human evolution, and hominid evolution, and hominid behavior. So it's very important. It's revolutionary evidence, and it's been analyzed. More analysis needs to be done to test things, but it definitely needs to be published, right? So, in conclusion, with all the press that they've ginned up, I have to say, I'm very disappointed in the excavators for not revealing what science is actually like. Science is not perfect. Science is conducted by humans. Humans are biased, lazy, mistake-prone people, right? That's what we all are, all of us. And to just go out there and tease this and present it as firm and lead on journalists to present it as firm fact is not honest. It's not honest about what science is and how it works. And I hope that this video, this informal YouTube peer review, gives a better sense, one, of how science is a process and how our evidence is not always perfect, which is true not just for archaeology, but a whole lot of fields, and how peer review can actually strengthen an argument. It's not just about accept or reject. When something has made it through peer review, it does not make it fact. But when something has been made it through peer review, hopefully the reviewers have helped make the final product that much better. And that's the goal here, right? Because science is an imperfect, messy, muddy, laminated orange-red mud with breccia. That's what science is in general. So, all right. I think my dad would not be very happy with this paper. In fact, he would have wished that they had taken some of his thoughts to heart. And he always argued about how so many of the burials that he was thinking about were excavated with very early methods. This is an opportunity to do better. And I really hope that as they continue their excavation, they give it some thought. Go read some Harold Dibble articles. By the way, I have links to some Twitter threads and some other videos below. Hit subscribe. And please, say something in honor of my dad. He is so missed by so many people. I can't describe it enough. And if you are so inclined, have a sip of scotch. I miss you, Dad.